So today, let's take a look at how we might be able to create some fixtures of our own for use in ESPRIT EDGE. To start out, what I'm going to do is I'm going to make sure I'm in a metric template or a blank document that's in metric because we're going to be taking some measurements in here and we want to be able to translate that over to Machine Tool Builder that we'll look at later, which runs in metric. So what I'm going to do is I'm going to pull in the solid models of the table I'm going to be working on. Let's navigate to where that is saved. I've got this step file for my Haas Rotary table. I'm going to open this. It doesn't need to be set to be a new part because we're not going to be programming this. We are just using the solids and then saving them out. So here we have our rotary table. First thing I'm going to do here is I need to set the origin point to be right where the base of the table is. So we want that origin to dictate where this is going to be mounting. And so I think the center point of this bottom piece will work. I'm going to get rid of a couple of these solids that are not needed within ESPRIT. I'll just delete those here. Then what I can do is I'm going to create a line straight from the top to the bottom here. So I can come to geometry, create a segment 2, letting me choose 2 points. We'll just use those 2 center points. Now I can create a point and snap it to the center of this line. So now we have that perfect center position. And what I can do is we can look at it, we can see what the values are for its location. And so we could either just translate and enter those manually, or what we can do is I'm going to select everything here. It's just a drag and drop. I'm going to right click copy. I will say translate. We're going to be moving it, not copying it. And I'm going to use 2 points. So then I can choose this point that we created and choose the origin point. And it should move that origin right to the bottom of our part, or more accurately, move our part to have that center point at the origin. Now, the next thing I notice is we have the x-axis pointing inward towards the face. What we might want is that x to be pointing outward. So I'm going to rotate this table now, still with everything selected. I can right-click copy. Instead of translate, we will choose rotate. I'm going to set 180 degrees in there, and I'm going to uncheck this box so I can make sure that I select the correct axis for it to rotate about. I'll use this Z, and it'll rotate that around so we have the X pointing the direction we want, which is perfect. The next thing I'm going to do is I'm going to create a point at the center of the face of this rotary plate, and that's going to allow us to measure where we want to have our attachment points later on. So I'll create a point, we'll snap it, and that looks like the front. You can kind of turn to the side here. That looks pretty good. Yep, right at the front. So now that we have all of that, what I'm going to do is I'm going to select all of our solids, and I'm going to deselect our geometry here. So we've got all of our solid elements, and I'm just going to come to File, Save As, and then I'm going to change the file type to be a fixture file GDML. And then I can give this a name. And I will save it to a location I'll be able to find it. Once that finishes saving, then we can move over from ESPRIT into Machine Tool Builder. Now in Machine Tool Builder, we're just going to open that file we just saved. And when this opens up, Okay, let's see here. Controls. So there we have the top, the bottom. And so what we see is when we click on this base node, it has it set to that origin point that we had. And so that's where it's going to attach to the machine's fixture attachment point. Now what we can do is we can look at our solids in here, and we might need to clean a few things up. So as I look at this, I can also notice that we have some screws that go between this front plate and some of these inner workings. And so that could cause some unwanted collisions and things like that. So what I'm going to do is find those specific parts, and I'm going to delete them out. So an easy way we can kind of play with this is I could select a large number of pieces and just see what it includes. So I see those 6 bolts are not included here. So I can grab another section. I can see, okay, that's got most of them. If I click a few extras, I can see, there we have the last one. Then I can deselect the pieces that I don't want. And we'll just make sure we keep those 6 bolts selected. Here's another one of our bolts. Okay, so we've got our 6 bolts there, and I'm just going to hit the delete key and remove those. Then what we want to do is find this rotary plate on the front. So it looks like it's in this first group, so we can just click through until we find it. There it is. And for this one, I'm just going to rename it and I'll just call it the rotary plate. And so then we can find that easily. Now, we could do some things with visibility here. If I want to hide this, let's see here. Typically, you can hide these with the little eye buttons we have. Doesn't look like it wants to do that for me. So what I'll do instead is just kind of look here, and maybe I will cut this out and see if we're going to have anything else that might cause collisions. Looks like possibly some of this, these solids here. So this just takes a little bit of cleanup because you don't want things overlapping when they're not needed to. So here's that piece. I can delete that. And so now we have a lot of those inner pieces gone, nothing that's going to be touching our front plate. So I feel better about that. Now I'm just going to paste my rotary table back in. So now that we have placed our plate back on, we don't have anything that will really get in its way. What I'm going to do is I'm actually going to combine all of the solids that are in this area. And the only solids I'm going to deselect are the ones that are going to be moving, which is just going to be this front plate. So once I have all those selected, I can right click and combine them into a single solid. Might take a minute for it to think. But once it's done, now we have the rotary table plate and we have the table itself. So I'll just call that one the table to keep track of it. So now what we want to do is we have these workpiece and fixture attachment points. And what we're going to do is we're going to move those along with our solid to a new location where we can edit and translate them together where we need them to go. So what I'm going to do is I'm going to right click on this base node and insert an item. I can add a new group. And then inside that new group, what I'm going to do is add a rotation axis. And then I can change the name of that if I want to be A-axis. Rotation direction is around the X. And I'm going to disable the use of limits so that it can just keep spinning around and around. Now off of this A-axis, I am going to create a new group, and that's going to be for the solids. So what we'll do first is for this A-axis point, because right now, if we spin, it's just spinning like this. So what we'll do is I'm going to come down, I'm going to change this to rotate around the X. And then the rotation center is what we want to change. And so I can change actually the location up here of the entire group. And so what we're going to do is move it by the distance we have in ESPRIT. So we'll come back. We can look at this point that we created. So we have 95.25, 0, and 127. I'm just going to Control C to copy that. And we'll see if it'll let me put it in here. There we go. So I can just take out this 127 now and put it in for Z. And so now it has moved that up to this center here. And now we can see the A-axis is affected by that. It's got a parent-child relationship. So now it is sitting right there. If I rotate around, it's rotating about that X-axis, which is great. And so now I need to add my solid here. So I can drag and drop it into there. And we'll see it takes the location and moves it by the distance we had selected. So now what we'll do is we'll just put a negative version of that into this solids node so that it comes back home. So we had 95.25. And we'll do a negative 127, I believe. So that brings it home. And then if we play around with this A-axis, and we can see it moving just as we would want it to. You can change the axis direction here with a negative sign if it's spinning the wrong way for a positive rotation. And let me see what I think about it here. Looks about right to me for a positive rotation. So I'm going to leave that. So now the last thing we have are these workpiece and fixture attachment points. I'm going to select those and I'm going to attach them to this node down here. And so now our workpiece and fixture attachment points are also on this front piece. So when we add a workpiece or an additional fixture, it's going to use this point to attach them to. So now we've got everything set up in here to where it functions as we would expect it to. And so now I can save this. When I click save on it, the little star disappears from my name. And so I know it's saved. Now we could come back to ESPRIT and we could test this using the machine axes. So I could just add a random machine here. Let's do a Haas VF4. It'll think for a second as it pulls that in. And so now we have our machine. I'll turn off this full machine definition, and now we can see our table. Now we can add a fixture and navigate to that new rotary table we created. When I throw it in, you can see it places it so that our rotary is right in the center of that table. And then within ESPRIT, of course, we can play with this as we want. We could translate this in the X direction. We're in metric here, so you can throw some numbers in here to move it to the position you want. You could probably move it in the Y a little too. And so you have control over exactly where it goes, but it's always going to start out with that fixture attachment point of the machine and puts it with the origin of this machine or of this fixture. And so that's how we can create that. And then we can test out that axis over here. We have our machine axes, and we'll see this A axis has been added. And as I move this little dragger, you can see the rotary table moving as well. So I see this functioning just as I would anticipate. And so that is what you need to know for building a rotary table.